All right, good morning, everyone. How we doing? Day 2, JNUC, how we feeling? Good? All right, hopefully we've been enjoying our morning. I've been asked to introduce this next session a very specific way. Enterprise security standards in action, right? The future of identity integrations with SSF and CAEP. I am using a cheat sheet with Dan, Mike, Atul, Matt, and Sam Weiss. Take it away.
Thank you everyone so much. Happy JNUC Day 2? Woo! Awesome. All right, forward-looking disclaimer. All right. Hey everyone, my name is Sam Weiss. I'm a Senior Alliance Partner Manager here at Jamf. As you all know, JNUC is one of the greatest places to hear about things that are new, exciting, and are at the direct intersection of devices, identity, and security. This session is literally all of those things. We're going to talk about some brand new concepts in the software world, things that are driving changes within companies when we talk about integrations and interoperability. I am thrilled to be joined by a powerhouse panel here of tech titans changing the way that everyone thinks about interoperating with each other. So without further ado, let's meet our panelists. Matt, I'll have you kick it off.
Yeah, hi there. My name is Matt Valisak, VP of Product Strategy and Solutions Engineering at Jamf. Go ahead.
Me?
Yeah.
Hi, everyone. I'm Atul Ruchibagwale. I'm the CTO of a company called Signal. So Signal is a company that believes in continuous identity. What that means is that we believe that it's not enough to just evaluate access at the time of sign-in. You need to do that continuously, and you need to adjust the access based on signals like, let's say Jamf says, your device is no longer compliant, then how do you revoke access to AWS or something like that? So learn more, go to our booth. I'm also the OpenID. OpenID is the standards body in which this shared signals and CAPE standards that we're going to talk about were developed. I am also co-chair of that working group along with Mike, and I'm also a co-chair of the OpenID AI Identity Management Community Group.
And I'm Mike Kaiser. I'm Director of Strategy and Standards at SailPoint, which is kind of enterprise identity governance. Wow, a lot of SailPoint fans out there. That's unusual. So I do a lot of different things, a lot of think about the future. Like Atul said, I'm newly co-chair of Shared Signals Working Group. I'm also co-chair of another working group with OpenID called Death and the Digital Estate. And if that intrigues you, come find me later.
Hey everyone, Dan Heffley, product manager here at Okta, running our Okta Device Access and Identity Threat Protection products. Identity Threat Protection is all about our continuous access evaluation, continuous authentication, just like everyone here is talking about, and leveraging all of those shared signals from all of our partners.
Awesome. So just to kind of give you a rundown of how this session will go, we know that shared signals are a brand new concept to a lot of us. So before we get into the panel conversation, we want to give you some background. What is it? Why does it matter? And then we'll dig into questions that we have. But we also want to open up questions to you all. So this has the opportunity to be interactive. So if you have burning questions, there's literally nobody better to ask. So with that, let's just kind of give some background on integrations, why they're important, and we'll go from there.
Yeah, great. So I mean, integrations in general is what it takes for an enterprise like architecture to come together. I mean, we're all focused in our different domains, Jamf with device management, Okta identity, SailPoint, and so on. And so how we make sure we have all of those services talking to each other to get to those like zero trust outcomes is very important. Because that doesn't just happen automatically. You've got a lot of security domain things you have to worry about. You want to have vendor choice for a lot of those selections. So one of the challenges that we would always have as a product management team is like, well, which vendor do you pick? And then how do you get prioritized roadmap to build that thing? And then how do you maintain that thing? I mean, Sam's been in the trenches with this for some of our proprietary integrations, and he has to be the advocate for it constantly to keep those things up to date. What's amazing about shared signals is that you can actually, it's a standard that is available for all vendors to accept and to utilize to allow for that signaling of real-time information that helps formulate a zero trust ecosystem. So it's a relatively simple framework. It's based upon Webhooks and JSON formats, so it's not like a really weird, complex thing, so developers can understand it very easily. But crucially, it's a build once and integrate with many sort of architecture, and just love that. So, and some of the use cases you see, this like if this then that. So, if we're able, so for instance, if we on the Jamf side detect that your device falls out of management, happens. let's go ahead and signal that, because you don't want a now unmanaged device to be able to log into stuff with Okta, for instance, to sensitive information. And you can imagine all the different use cases and different kind of software agents on those devices, whether it's a Mac, a PC, to be able to inform what's happening across the entire architecture.
Yeah, and let's dig into a little bit more of that pain with traditional API development. Dan, you want to speak to this?
Yeah, absolutely. So as Matt was mentioning, there's a lot of prioritization on the product side of, who do you want to integrate with, how do you want to integrate, how do you want to secure that, how do you want to maintain it. So traditionally, it's always been a one-to-one, and you have to have that relationship and share API tokens, API versioning, things like that. And it's very hard to prioritize those as a one-to-one relationship and to maintain them. It's a very brittle relationship going forward.
But there's a better way. Mike, you want to tell us about it?
Yeah, I'm a little bit biased. I mean, standards is in my title, right? Like, I am an idealist. I have a lot of conversations with people, and historically have over my career, where they say, why doesn't this just kind of work? Why are things falling over because y'all decided to do something different, or one side didn't agree? That's the idea of standards, right? Is that you code to a standard. And assuming you meet the agreed upon standard, ideally you walk into a room, you say, I've got one end of this relationship, you've got the other, let's integrate them, and you turn it on, and usually it does. It had that experience with a couple of interops with shared signals. I think Sam and I have talked about this before, where it's kind of thrilling when you walk in cold without really talking much, and you turn it on and it goes buzz and does what you want it to, right? So that's really the power here, is having that common agreement, saying, yes, this is how things should work, go off and do your own thing, walk into a room, and not just one vendor. Last week I was at my own SailPoint conference, and I had customers say, well, what vendors is this for? And I say, yes, anyone who supports it should be able to walk in that door and hook in and feed in or take events from SailPoint or any of these components. And that's really thrilling.
And to Matt's point, this flips the industries on its head. Traditional API development requires relationships, resources, documentation, NFRs, and yeah, as Mike said, we've done several interops at Gartner where I've walked into a room with vendors I've never met before. And they say, I have an SSF receiver. And I say, I'm an SSF transmitter. Let's deliver outcomes to customers. And just that reduction of time that it takes to get to value is just incredible. And Atul, tell us how this came about. How is OIDF involved in kind of setting the standard so that we all play in the same sandbox the right way?
Sure. So shared signals actually is the outcome of two different standards. So there's a standard called RISC. It's called Risk Incident Sharing and Coordination. It's more about account security. And CAEP, which is Continuous Access Evaluation Protocol, as it was called at that time. They both came together, and we formed the Shared Signals Working Group in the OpenID Foundation. And that defines sort of the underlying layer of how different entities can communicate. And CAEP and RISC now are just a set of events that you can send using that shared signals layer. CAEP specifically is about session security. So for example, like a device going out of compliance is a session property. There's nothing wrong with the account as such. It's just that your login session should not behave the same way as it used to, because now you're on a non-compliant device. Or you change your password, that's a credential change event. It's a CAEP event. And so we are trying to build this in a way that is asynchronous, which is what the shared signals framework gives you. And why that is important is because every organization is going to have different sort of response times and different availability characteristics. You still need a reliable way of getting your events across. And then the CAEP events are non-prescriptive. So what that means is that because each organization is going to have their own policies, you don't want to force an organization to take a certain action. What you're saying is that, hey, I'm observing that this device is out of compliance. Now you decide what you want to do with that information, right? So it gives the other party the freedom to do their own policies. And so this is sort of how CAEP and RISC and shared signals all came together.
Yeah, and this transition, just highlighting a tool, is very involved with this community, and is, I think we call you the godfather of SSF and CAEP, if I'm not mistaken. His history on this goes way back, so again, if you have questions on this, please grab us after the session, because there are no better topic experts on this.
And Sam and I have been talking since my days at Google, when some of this was very new, actually.
Yeah. All right, so now let's talk a little bit more about how this works. I'm going to have Matt and Atul kind of talk through the flow here.
Yeah, so basically what happens is you see there on the left, we've got the party like Jamf, who's going to be the transmitter in this relationship, and we have receivers on the other side who are, like the Okta and SailPoint and Signal in this case. So what ends up happening is, well, or are we doing the other way around with this one? I can barely see the thing. But like it's, so yeah, in this case, what we're doing is we're setting up a webhook, because that's what's happening here?
Yeah, what's happening is that you're setting up the stream.
Yes.
So shared signals, the basic concept is a stream. So you create a stream on which you can now send events and receive events, right? So the receiver tells the transmitter, I want to create a stream through which you can send me the events.
Yep, that's right.
Right? And in the description, you're saying, oh, I would like to get all these events from you. The transmitter might say, well, for you, I can only give these events. And you can define which subjects you want the events for, and that's sort of what that arrow seems to
keep on going, yeah.
Sure, so what actually goes on the stream is a JOT, like this is a signed JSON object, right? So it's called a JSON Web Token, colloquially known as a JOT. And so there is a specific type of JOT that we have adopted in the standard called security event token. So it's a JOT, but it has this events claim, which describes what that event is actually about, right? And CAPE defines specific events, like I said, device compliance change or credential change or session revoked, or there's about 9 of them now, maybe risk level change and stuff like that. And so what you're seeing is that once the stream has been created, the transmitter asynchronously sends these events to the receiver, right? And so the transmitter gets an acknowledgement from the receiver that, oh yeah, the receiver says, I've received the event, don't worry. Or it can say, I had an error, you need to send it again, or things like that. So it's a very reliable way of doing things without assuming any kind of shared infrastructure. Like normally when you're doing this in an enterprise, you might be using things like Kafka and stuff like that. You don't assume any of that with shared signals. It's just HTTP.
Yep.
And we are essentially implementing that reliable asynchronous layer using shared signals. Now here, what you're seeing is the details of an event. So as you can see at the top level, you describe the subject, and you can describe the subject in various ways, right? So, an identity provider like Okta might say the subject for me is an, email address, right? Jamf might say it's a device identifier.
Yep.
Or, various ways.
Yeah, exactly right.
And so, and then the rest of the things that you see, like, there's a lot of stuff so that, you don't get these repeated events, like, Jamf sends us an event, and then, we send SailPoint an event, and SailPoint sends one back to Jamf, and it's not like generating multiple. So there's some ways to prevent that and all that. So anyway.
But yeah, essentially it provides a very clear, easily human readable, but a description of like who the subject is. It follows a very common format, and then the event type is very clear to understand, like, is the device managed, like compliance, those sort of well-defined types of events we are able to submit or transmit in these JOT tokens.
Yeah, and Matt, before we go to the demo, can you share just a little bit about what Jamf deems compliance to be in our current shared signals framework?
Yeah, so we have, like, if the device is managed is probably our most important baseline. Like I mentioned earlier, if the device, if it is, again, some weird things happen sometimes where a device can become unmanaged. That, for most customers, is actually one of the most important things to know, because that device management footprint is actually the foundation of all zero trust. Then for the rest of compliance, we allow you to do things like with smart groups to be able to define whether or not a device is in compliance based upon your smart group criteria, and we can emit that as well. And we have further integrations that we're working on with our compliance benchmarks and so on. So all this starts to tie together to make it really simple and straightforward.
Yeah, awesome.
Just one thing to add about the standard before we get into the demo is, like, other than the companies here on stage, we also have support from Google, Apple, IBM, many leading companies who are fully supporting the standard now in production. So.
Correct, and growing. We're working with the
Yeah.
community every day.
Yeah, every time there's a shared signals working group meeting, it's like, who's this new company that's joining? And there's companies implementing that are not part of the working group as well. So it's a big community, and companies can decide how involved they want to be in it, implementing or brainstorming on ways to solve new problems. And that's been really awesome, being a part of the working group. Actually, Atul, do you want to let us know, like, where are we at in terms of the spec?
Right. So we just achieved, the spec was ratified as final. So we went through 3 revisions before it came to the final spec. Every time the number of changes we had to make was smaller. And so now it's final, nothing to stop any of the developers from adopting it because it's not going to change anymore. We are still working on things, but those will be a subsequent release of the spec. And you can expect support for the final spec across the board, now. Like, I would, I don't want to sound too like pompous here, but what I would like to believe is that because of all the support I'm seeing, this is going to be the asynchronous transport layer of the internet. Like HTTP is the synchronous transport layer, and I think shared signals has the opportunity to become the asynchronous transport layer of the internet.
Yeah.
Amazing. Okay, we're going to see a few demos. We've talked about this hypothetically. You understand the why. We're going to show you 2 demos. The first one is that device compliance demo. So again, as Matt said, we transmit when a device falls out of management. That's that great baseline for compliance. And in this demo, and one of the cool things about SSF is you can integrate with multiple partners. And as Atul said, there's logic to make sure we're not doing bad things to infrastructure. So in this demo, you're going to see Jamf send that signal to SailPoint and Signal. As Atul mentioned, the policy engine is all within those platforms. Jamf is not saying do this. Jamf is saying we see this. And also, this is a great demo, so I would love some applause at the end with that great energy T started us with. So let's take a look here. So in this demo, this is Jamf Security Cloud, which is where you set up SSF streams. And as you can see, we've set up 2 streams to SailPoint and Signal. In Jamf Pro, we have a Mac that's currently managed. So let's see what unrestricted access looks like. And yeah, so this is Signal.
Yeah, we don't have a UI, but you're using Signal behind the scenes.
Yep.
Yeah.
So as you can see, the employee can get to an AWS S3 bucket just fine, and SailPoint is doing a similar thing on the Jira side. So this is unfettered access, everything is normal. Now this device is going to be removed from Jamf, unmanaged, deleted, marked as unmanaged, lots of ways that can happen. And what you can see is this CAPE device compliance event was sent to Signal, and this is the Signal UI, so I'll let you speak to this.
This is the admin UI for
Yep.
Yeah. And so you saw the jot come into Signal. Here I'm just showing that that's exactly the event that Jamf sent us. And now if you try to do something in AWS, what Signal has done is taken the device compliance event, and it has actually translated that into a proprietary integration with AWS to remove access for the user from AWS. So the moment your device falls out of compliance, they can no longer access anything in AWS.
I mean, it's almost like the moment. It's very quick, right?
Yep.
Yeah, and SailPoint's doing the same thing here with its own world. It's saying, what privileged access does it have that you need a compliant device to access, and it's removing that in the moment as well. So basically, it's everyone acting as an informed actor based off of what Jamf has sent. What do I know about? What do I control? Let me take the actions the business expects me to take on their behalf. We're doing certifications and compliance, the normal governance things you'd see from SailPoint on the back end here as well.
And that was our successful demo. All right, and we've got one more, and I'll ask you to clap after that one too. So for our next demo, slightly different setup. This is Jamf to Okta, and we're doing the risk change. And so this would be in Jamf Security Cloud if malware is detected, if a phishing link is clicked. That is what changes your risk score. So Dan, I'll let you kind of talk us through this one.
Cool, sounds good. So in this case, we're gonna have a user that is trying to access their email. You can see here they're already logged in. They've accessed their email, they've accessed it through Okta FastPass, phishing resistant, devices managed, things like that. And then they click a link in their email thinking it was something they needed to interact with, and that turns out to be malware. So Jamf Security Cloud is able to detect that, and as you see, the device is at risk, and that's sent asynchronously through SSF to Okta, and on our end, you can use the policy engine to determine what you want to do. And so in this case, we have the capability of universal logout, which is killing your Okta session as well as downstream sessions for your crown jewel apps as well. So you can see there the dashboard session has been revoked, as well as Salesforce, Gmail, things like that.
Right on. So you've heard why, you've heard how, you've seen 2 demos. At this point, like I said, this is literally the best crew to be asking questions from. So we have some questions that we thought would be super relevant, especially given the Apple-focused audience here. So we're going to go through some. We'll show you how to build your own receiver in Postman, and then we'll open up questions to the audience. So to start, Atul, tell us a little bit about where shared signals came from. Like, why was this so important to you?
Sure. So shared signals actually has an interesting history because there's one part of Google which was working on risk, where they were thinking about, hey, if somebody's trying to compromise a Google account, and they might be actually trying to leverage that to compromise the Facebook account or the LinkedIn account and that kind of stuff. So it was a very consumer-oriented thing, but in the process, they defined the asynchronous layer. When I was at Google, I was like, I had no idea that this was going on, right? So I'm in a completely different part of Google. I come up with this blog post that talks about how you can, you need to rethink how federated identity is done, because right now it's sort of a fire and forget thing where you sign on a user and then you have no idea what that user is accessing, and you have no way of like telling the other party that something's wrong with that session. So sort of came up with that blog, identified this as a asynchronous way of doing things, and some of the things that are in the standard now. And then we find out that, the risk guys had just published the same kind of thing for account security, and we published the CAPE blog within a week or something like that. And so there was, for a year, we were on separate streams. And then the guys from the OpenID Foundation said, like, we already have risk, and you're working on something similar, why don't you get together and have the same standard? And that's how shared signals came about. So now shared signals becomes the asynchronous transport for any kind of events that you want to send. And the great thing is that now we have a group in the IETF, which Mike Kaiser is very much a part of, which is doing account updates using shared signals. That's called SCIM events. And so you can see that this now transport layer is being adopted, not just by CAPE and risk, it's been adopted more broadly as well.
Yeah. I'm going to move some of these questions around. Dan, we heard at the beginning there's some major players involved in this. Google, I think we heard the word Apple. Can you tell us what is Apple doing with shared signals?
Yeah, so Apple previously has limited their IDP integrations, but now I think last year with DubDub, they announced that Okta could integrate with Apple Business Manager. So now you can have managed Apple IDs with Okta, and you can send those SSF events downstream, and Apple actually has an SSF receiver. So you have things that, whether it's through the session context reevaluation within Okta, or you get signals from Signal, SailPoint, Jamf, and that causes a universal logout. We revoke the session. We send that session revocation data down to Apple Business Manager, and it causes the managed Apple ID to prompt for a re-authentication to ensure that your devices are always secured.
I was pretty blown away being part of these shared signals conversations, and then hearing like Apple is actually doing this. I think kind of is a testament to the durability of the pattern and the flexibility of the outcomes.
Yeah, if I could just add, and what's really cool about it is that logout is actually taking place on the device, because as Apple moves more towards managed Apple accounts with iCloud services, continuity services, all those other sort of things, being able to manage the data that is organizationally owned and what services you have available through a managed Apple account becomes really important on those managed devices. So this is a proper logout on the device that happens in real time that is helping to gate that access to the Apple ecosystem that is being built out.
Yeah, Matt, I think you mentioned something just now that I don't think has been stated clearly, but this is very much all in real time, which is really cool. None of this is delayed or every 15 minutes. There's no polling interval. It's all in real time.
And it's all cloud to cloud. That's the other important thing. There's not an agent on these devices. There's not an agent on, it's not like self-service on the Mac is sending a signal out to any of these things. It's happening from cloud to cloud, from the Jamf Security Cloud in our case over to the Okta Cloud. There's no agent dependencies that could be susceptible to other sort of interception and those sort of things.
And the other notable thing about Apple is that they did not attend a single working group meeting.
Yeah.
Right? And I'm receiving these strange questions on email about the spec from Apple. I'm like, okay, yeah, they're curious, so I answer them. And a few days later, I found out in WWDC that they've announced support for SSF, which is incredible.
Yeah.
So anybody can implement it. You don't have to be a part of the standards, mafia.
That's actually, just to double down on that, we're actually having a lot of discussions with customers because this is all standards-based, and we'll talk about how to build your own receiver and transmitter, and there's open source available. We're talking with customers who have a mature risk engine already in-house and through your SIM, things like that, that are actually building transmitters to send and receive with.
So 2 semi-related questions. I'm going to send the first one to Mike. So Mike, as software developers and software companies, we like believing that we know what our customers are doing with our software. The interesting thing about shared signals is we don't know what anyone is going to hook this up to or what they're going to do with it. So how has that changed conversations internally at your company? Are we open to the idea of people using software in ways that we didn't necessarily intend or envision?
Yes and no, I think, is always going to be the answer, right? If I were a product manager, I'd want to know everything all the time about how my users are going to use this. At the same time, there is a intoxicating something, pick your subject here, noun here, that where what you really want to do is you want to build vision for people, right? You want to build things, you want to build tools where people can go and meet their business need and get real benefit out of it to where they'll go tell their friends in the industry or even their families, hey, look at this cool thing I did, right? So there's always going to be, I think, a balance there of making the structure strong enough to hold up when they get crazy ideas, but not let them shoot themselves in the foot, but enable them, right? So I think there's a balance there. Like Atul mentioned, the SCIM event standard in IETF and the SCIM working group. It doesn't have to use shared signals, but it can. And I think it should as shared signals gets adopted. That's another thing where I don't think we started out with shared signals thinking, oh, we could do SCIM via event basis. But once you have that plumbing in place, I tell people the world is kind of your oyster. There are standard events. Those events could be overloaded. You could have wholly new events as long as the transmitter and the receiver agree on what that event should look like, what it should be, and as long as it meets a use case. At the end of the day, it always goes back down to incentives, right? Is it available? Does it meet a business need? Can I actually do things with this? So it's kind of changing the mindset in a way, I think.
So Matt, kind of on that, do open standards challenge competitive advantages that have traditionally been brought on by direct API development, and is that okay?
Yeah, in my opinion, I think having closed ecosystems is not just going to help us with this battle against security. You know, it's a team sport in the end when it comes to this sort of stuff, and having these closed vendor lock-in sort of things is not really helping anybody with innovation and helping move the ball forward. So having open standards that, you know, we push our partners to work. If you want to work with us, like we could say, hey, well, we have something here. Let's make these solutions and work out together to help our customers solve problems in new and novel ways, and not require a big business case and thesis before we engage with a partner and hope that that integration ends up working out. You could iterate a lot quicker and prove concepts out and see that this is actually a way of solving real problems before you invest heavily in any one given partner and pattern. And again, at the end of the day, you can find some really novel ways of doing things.
Question for Atul and Dan. I think you'll both have some maybe different perspectives on this. Most enterprises have existing infrastructure. They have existing compliance policies and technology. How do you modernize for CAEP and SSF without completely ripping and replacing?
So I think it's actually great that CAEP and SSF don't take a very prescriptive approach to what you have to do, right? So you don't have to necessarily rewire how your product works or things like that. You're just getting new information that now you can use to enrich your decisions, right? So it definitely complements what you already have. You don't have to, if I have Okta as an IDP, and Okta already has a way of logging out users, they don't have to suddenly change all of that because they are now supporting SSF. All they're getting now is a new device signal from Jamf, and they're saying, okay, yeah, I can use this to make more informed decisions, right? So.
Yeah, I definitely agree there of you're pulling in signals that weren't available before, whether it's through SSF partners, which, there's a lot more SSF partners than what you see on the stage today, or whether it's through like I was just talking about, building your own, sending your own transmitters. And it's really the power of the policy engine on each partner as well that has the receiver to say, hey, I noticed that this came in, and now here's what I can do. Whether that's resetting the password, adding them to a user group, doing that logout, things like that. We all have examples of what we can do with our policy engine that is extremely powerful to tie together that you couldn't previously do. And the beauty of it, as Mike was mentioning, is it's all standards-based and it's all flexible as well.
Awesome. So let's actually dive into some of that flexibility. And just to give a map for the next 13 minutes, we're going to talk through how you can use Postman to build your own receiver, test this out, even if you have some tools that are SSF transmitters, like Jamf. I'm sure you all have Jamf. If you don't have Okta, Signal, or SailPoint, you should talk to them because they can probably be helpful for you. But you can also create this receiver yourself to see what this looks like. So Atul's going to walk us through how you can use cape.dev, which probably needs an introduction before we start the demo, and then how you work with Postman on that.
So let's say you want to develop your own receiver for Jamf's device compliance change events, but you don't have a way of generating events on demand, right? And that's where cape.dev comes in. It's a free service that anyone can use. It's a non-commercial service that you can use to test your own receiver or transmitter. So you can go to cape.dev and say, hey, send me an event, and it'll send you an event. Or you can say, I'm going to send you an event, show me that you received it correctly. So it's just a way for people to develop transmitters and receivers. Here, what I'm going to show is, assume that what you're seeing by way of cape.dev is actually just Jamf, and you're developing your own receiver to receive those events. And let's go through the demo now. So you see here, I've gone to cape.dev. It's got a bunch of stuff in there. It's not just a transmitter and receiver. It also has a little bit of a learn section where you can get to know about the standard. It'll tell you how to use the website, but it'll also give you some details like a FAQ and some presentations about understanding CAEP and SSF and things like that. And so let's say you've done all that. Now you want to do your own receiver. You can use this developer section. There's some open source receivers that you can download and integrate into your products. And here you're going to a transmitter, And I've gone through the registration process, so I already have a token. And then what you're going to do now is start receiving. Well, what it's going to say is that, well, you haven't actually created a stream yet. You need a receiver to have created a stream for me to be able to send you events. So what I'm doing is I'm downloading the Postman collection because I don't have a receiver. I'm just going to build one using Postman on the fly, right? So it downloaded the collection, and here you see I'm going to import that collection into Postman. And when I import it, I'll see all the SSF things I can do with that Postman collection. Within that, you see there is a way to create a stream. There's also a way to poll events as a CAEP receiver. You see that there. So all of that is already available to you. Now, what I'm going to do is I'm going to try and set up a stream. Now, before I do that, I need to put my access token in so that the transmitter knows who's requesting to create the stream. So I'm going to grab my access token that I already received as a part of registration, and I'm going to put that into Postman so that the receiver can authenticate to the transmitter, right? So, and now I'm going to just create a stream. So what you'll see here is that I just hit the post button, and it'll create the stream for me. And so you see the response from cape.dev. It's telling which events are available to you and all those things. Mm-hmm. And so now what I'm going to go do is start the stream. So last time I received an error here, but now I don't because the stream has been created. And now you see all the events that are available in that stream. I'm going to go for the device compliance change because that's kind of what you would expect from Jamf. And I'm going to use email as the subject. This is just for testing, right? So, and the device was compliant and is no longer compliant, and I'm going to send that event. So now it says that the event has been queued. SSF uses 2 ways of transport, push and poll. This is using the poll transport. So it just queued up the event, and it's waiting for the receiver to poll for that event, right? So now I go to that poll event part of the Postman collection, and I bring down that event to me. And so if I now paste this event into jot.io, then you'll see, and thanks Okta for having jot.io. And so you'll see that in a minute, you will see that the event actually is what cape.dev sent me. All right, there you go. So you see the same email that was entered on cape.dev, and you see the device compliance change event, and the device was compliant and is now no longer compliant. So it's very easy to build a receiver. There's open source, there's the Postman collection, there's a site where you can test all this without having to worry about it. So what's stopping you?
Let's get another round of applause for another demo. Okay, so we're going to talk about some resources where you can learn more. I think we'll probably have 5 minutes for some Q&A. So if you want to learn more, you have a lot of resources. The Jamf developer portal has a specific section on our compliance signals and what to expect. The OpenID working group, fantastic. You can sign up and get notes from meetings, and you can participate if it's something that your company is interested in doing.
And read the specs.
And read the specs, yes. All the specs are there.
All the specs.
The ratified specs, yep.
Yep.
We got cape.dev, which you just saw the easiest way to test out creating a transmitter or a receiver. There are the open source collections, and there's a really great website. This is Cisco's website, right? Cisco. Yep, so sharedsignals.guide. Cisco, another very important member of the working group. This resource has existed for a while, and it hasn't had to change very much because it's all still very accurate. Yeah. But yeah, that's another great resource.
Yeah, and that last one, if you had someone that said, what is this all about? It's a great place to even send like executives to potentially, because it's very visual, very cartoony, but very informative. So it's a great place. And then if it's a dev person, engineer, they can always dive a lot deeper as they go as well.
Yep. The other thing I would mention based on that is, as you leave this session, you look more into SSF across any of us as well, and you see any partners that you're talking to or you already have in your environment that are not part of SSF, let any of us know, or your account team, and we can spend all day. We do spend all day talking with those partners and getting them up to speed about what SSF is and how they can be involved as well.
We'll walk in, we'll say, look, we can do this the easy way, we can do this the hard way. No, we won't do that. But customer voices make a real difference with product management, right? Say, look, here are 10 customers waiting on you to support this. What can we do to help you move along into the standard?
Yep.
I think one of the underlying things we heard at the Gartner conference, their advice was demand your vendors support SSF.
Yeah.
And that definitely does make a difference. So with that, let's give a huge round of applause to our panelists. And we've had some good questions, but we have 5 minutes and 40 seconds for questions that you all have.
Very cool. If you have any questions, go ahead and raise your hand and I'll run the microphone right over to you.
Phew. We at least have one.
Thanks for the presentation. So there was a working example regarding Jamf Security Cloud was sending an event to Okta, which would then send it to Apple. When you're having these kind of like multi-step workflows, is there a way of identifying, like from the Apple side, what the original trigger was, or is each step independent?
So the event has, depending on the event, right? Some events have a reason that you can put into the event, and they have a way to trace the event across all these multiple transmissions. So there's a specific field called TXN that has a value that is preserved across these events. So you can trace back to what originally caused the issue.
Okay. Other questions? So when you're having these like multi-step workflows, do you have any suggestions on how to organize that?
So each node in the network kind of operates independently. And so let's say Jamf is sending the event to Okta. Okta can have its own policy, or you can define the policy in Okta about what to do with that event. And if you say, hey, I want my Apple users to be logged out of their Macs, then that's the policy that it'll implement. So I'm not sure, did I answer the question?
Just like when it's multi-step, so like from Jamf Security Cloud to Okta to Apple, when you're having these multi-leg workflows, just kind of like, I don't know if it's just like a visual thing or if there's a suggested way of how to track all of these steps and how they're interdependent and stuff like that.
Yeah, I'll say specifically from the Okta side, every event that's received or transmitted is recorded in the system log. And you can go back and look at those, and to Atul's point, like all of the JSON that is sent through that event is visible there and can be parsed out through Okta workflows, for example.
You're going to want to think architecturally about what is in your environment, what supports SSF in the first place, what events they each support, and what role you choose to use them as, right? You might have multiple vendors that do a similar function, in which case you need to think through what are the pros and cons of having this component be in charge of this activity, right? Just like other activities, I'm not sure it's necessarily wise to have 4 components all try and log a user out. That's not quite ideal. There are some scenarios where that's just going to be a thing, right? Mainframe still exists, so someone's going to be a specialty there at the very least. But I think you're right that you'd be wise to have someone who is thinking through what is this flow, what does it look like, because we're all going to record it and we're all going to receive events and transmit events and take actions based off of policy internally. But it would be good to have someone thinking through what do I want as ideal behavior according to my overall business policy, and then make sure every component plays the right role within, right? Because what you'll hear always from every vendor is, I can do it all for you. And that's the opposite of what we're trying to do with shared signals, right? We're all saying it's a lot better when we all play together. Because otherwise, it's like running a marathon without a watch, right? I can do that, what happens? That means I'm relying on interactions every 10 miles to know if I'm on track or not. Disastrous way to do that. In between those time checks, it's nothing but risk. A lot of times that's what people do with identity or device management. They say, I'm only going to know and choose what to do when this component interacts with my end user. Much rather have everyone sharing information so you constantly get updates for each component to take informed actions. The equivalent of having a watch the whole time I'm looking at a marathon. I can say, I'm on track, I need to speed up, I need to slow down, I need to adjust in this way. That kind of a thing.
I'd consider the outcomes too. Like, just because, like you saw, we could emit to multiple transmitters when we have that, or receivers when we have an event that comes up. We could have emitted directly to Apple, because it's all standard, right? And then also to Okta. But I think what you want to look at is the outcome is I want to be able to do a user-oriented logout for this thing. So I'm going to architect my system so that I'm actually going to not go straight to Apple. I'm going to go to Okta, who's my identity broker for all these things, including Apple, but expect to define policy for that identity administrator to be able to then take policy not just against Apple, but the entire ecosystem. And Okta's in a much better spot to do that than Jamf, and also from a who owns that console perspective.
Yeah, the other thing I'll add is, in that demo, we're not just replaying that event that we got from Jamf Security Cloud. We're getting that, we're going through our policy engine, and then we're doing a session revocation. And what the event that we actually send to Apple is the session revocation event.
Everything is moving to event-based real time going forward. Everything's going to be at a different stage, so you'll have very similar effects, possibly, that look like similar activities, but slightly different. Access versus entitlement provisioning or deprovisioning, for instance. Both can happen in real time, depending on the target. You probably want both at the same time. I want to lock out, kill any sessions. I want to make sure that even if they end around whatever my gatekeeper is, that application has the right stuff. But there's a process to getting all that real time. So thinking through all of those cases would be important.
Right on. Well, thank you all so much. If you want to learn more about this, Okta has a booth here. Signal has a booth here. Stop at the API Jamf booth, and we'll have more conversations about it. But thank you so much, and have a great JNUC.
All right, thank you, speakers, and thank you, everyone, for joining. I believe it's just about lunchtime, right? So grab some food, and enjoy the rest of your day.